All right, so this is your review for Algebra 2, Unit 0, first quiz, first test. So, number one, factor completely. GCF might be needed. In fact, that's what we're going to start off with right here. So, we look at the numbers 6 and 33. 6 does not go into both of them, but 3 does. So, we can pull a 3 out. Also, notice they both have an x, at least one x. X to the first power, so we're going to take that out. And now we just start dividing. 6 divided by 3 is 2. X squared divided by x is x. Negative 33 divided by 3 is negative 11, and the x's cancel, and we're finished. And that's all we can do. That is the final answer. Okay, here we have a trinomial. Notice that our lead coefficient is 1, so that's a simple factoring where we're going to have x times x in the lead. And now we need numbers that multiply to give me 14. Okay. Remember, this tells us they're going to add up to something. We also know that that means they're going to be the same sign. And this tells us what that sign will be. So you know they're both negative. They have to add up to 9. So that's 2 and 7. So x minus 2, x minus 7 is our final answer. Over here, similar, except this negative tells you that they're going to have a different sign. Lead coefficient of 1 still, so x times x. But this time they're going to differ by 13. Well, if we look back at the previous problem, that's going to be 14 and 1. This tells us we want more negatives than positives. Okay? Now, if this would have been this 13 here, let's say that would have been a 5, then we would have used 7 and 2 again, with the bigger number being negative 7, positive 2. Over here, if this would have been adding up to 15, positive 15x, then we would use positive 1 and positive 14. So you can see how changing the signs changes the outcome of the problem. Now notice here we have a coefficient bigger than 1. So we're going to have more choices. But the nice thing is it's just 2. So we're just going to have 2x times x. It's the only way to get it. And then 15 is 1 and 15, 3 and 5. Not a lot of choices. Okay. And so I'm going to put the 3 here and the 5 here. And the smiley faces are really important here. Okay. That gives me 3. 3 times 1 is 3. 2 times 5 is 10. They need to add to 11. Well, this adds to 13. So that tells me I did something wrong. That means it's either 5 and 3, or we need to use the 15 and the 1. So let's try this again. First off, we just switch them. So I'm going to put the 5 here and the 3 here. That gives me 5. 2 times 3 is 6. That gives me 11. Same sign, both negatives. There we go. 25. Both numbers are perfect squares. I also want to check and make sure that there's no common factor to both of them. Like, let's say this was 36 instead. Well, then 9 could be pulled out. But since it's not, we're just simply going to go with square root of 25, square root of x squared, square root of 81, 1 positive, 1 negative. Just for the heck of it, let's say we did have 36x squared, bonus problem, minus 81. You could factor this to 6 and 9, 6x plus 9, 6x minus 9, but then you'd have to pull 3 out of each parentheses. But instead, if you just take the 9 out first, 4x squared minus 9, now you'd end up with 9 times 2x plus 3 and 2x minus 3. So sometimes we have a GCF before we do the other factoring. Case in point right here. You could break down the 15 to 1 and 15, 3 and 5. You could break down the 100 to 1 times 100, 2 times 50, and so forth. But if you notice, 5, 5, 0, they are all multiples of 5, which means I can make this smaller, 3x squared, 7x, and minus 20. Well, the nice thing about this is, when I break this down, there's only one way to get 3. 3 and 1. Don't forget to bring this 5 down. Most common mistake. Now for 20, we have 1 and 20, 2 and 10, and 4 and 5. Not a lot of choices. I'm going to throw the 4 and the 5 in first. Now remember, they have to differ by 7. So 5 times 3 is 15. That's good. That's over 7. But minus 4 only gives me 11. So that doesn't work. So we're going to try switching them. Put the 5 here and the 4 here. Well, 4 times 3 gives me 12. 5 times 1 gives me 5. And yes, 12 minus 5 is 7. I want more positives, so I want the 12 to be positive and the 5 to be negative. And there's my answer. Moving on. So this is y equals mx plus b form, also known as slope-intercept. Mathematicians not that creative. That's the slope, that's the y-intercept. The y-intercept is negative 4. That means I want to go on the y-axis to negative 4 and put a dot. And now my slope is negative 3 over 5, or 3 over negative 5. This means down 3 and right 5, or up 3 and left 5. Either way. Notice I really on this one technically can't go down 3, because if I do 1, 2, 3, I'm down here off the grid. Now I can get a general idea and go 1, 2, 3, 4, 5, and it's going to be somewhere around here, but it's not completely accurate. So instead, I'm going to choose to use this one and go up 3, 1, 2, 3, and left 1, 2, 3, 4, 5. Now you can see that pretty much lines up. Pretty accurate guess. And there's my line. Now over here, if you notice, 2 and 6 are both factors of 12. That means we can use the cover-up method. So the cover-up method means if I put a 0 in for x, like right here, 2 times 0 is 0. So that disappears, and I'm just left with negative 6y equals 12. So therefore, I'm just going to divide by negative 6, and y is negative 2. So that's the point, 0, negative 2, my y-intercept. And if this was in y equals mx plus b form, that would be my last number, negative 2. Now, I'm going to do the cover the method here. And when I do that, I'm plugging in a 0 for y, and that's going to give me my x-intercept. 12 divided by 2 is 6. That's right here. And I always use a straight edge. Ruler, ID card, whatever, and there's my line. Now notice this one over here has a negative slope. This one has a positive slope. I always tell my students if you can write your name on it and it's going downhill, it's negative. And if you write your name on it and it's going uphill, it's positive, even if it's slight. Okay, solve each equation. So first off, what we want to do is we want to distribute this negative 3 to both sides, or both terms, sorry. And we don't want to write 12 because it's 21. So on this side, we're just left with the 21 plus 6v. We're not doing anything else here. Over here, we have negative 15. And be careful, it's not plus 2v, it's minus 6v. Now, because of space, I'm going to add 6v cancel this and add 6v here. I'm going to minus 21 and minus 21 here. That cancels those. And that's going to give me 12v equals negative 36. And when I divide by 12, v equals negative 3. Now, I'm going to erase all this and show you another method if you saw it. Some of us have talked about the shortcut here. If you saw it. Since negative 3 is a factor of 6 and 21, I can just divide both sides by negative 3. That cancels there. Over here, I end up with negative 7 minus 2v equals just the parentheses, 5 plus 2v. And now, when I add 2v over to that side, I'm going to get 4v. When I subtract 5 and move to that side, I get negative 12. And when I divide by 4, again, I will get negative 3. So either method works. Some of you may have seen that, some of you may not. But it is possible as long as it's a factor of everything. Just another method. Okay, number 10. So here I have 7y and negative 7y. Those are like terms. I'm going to combine them. When I do, I get 7y minus 7y being 0, and I end up with simply 2 equals 2. This is a true statement. If it's a true statement, that means any number I plug in here and here will make a true statement, which means I have infinite solutions or all real numbers. You can write it either way, or you can literally write out all real numbers. On to number 11. Again, I want to combine my letters, which in this case, again, go away. They cancel out. This time I'm left with negative 3 equals negative 8. Well, that is a false statement. They are not equal. Well, anytime we get that, we can say no solution. Number 12, absolute value. Remember, you cannot do anything with absolute value until it's alone. Okay, which means we need to get rid of this 2 first. We always get rid of addition and subtraction first. So we have 5. Did not mean to do that. Goes to my next point. We cannot distribute inside brackets like parentheses. We can divide and get rid of it. And that gives me the absolute value of A is 4. That means some number is 4 spaces away from 0. Now at this point, since it's alone, we can split it. And all we do is we say A equals 4, A equals negative 4, and in this problem we're actually done already. Now in 13 there'll be another step. So we're going to minus 7 again, just like we did before, to get rid of the absolute value alone. But notice the absolute value over here is a binomial, not just a letter or variable. So when we do this, we still have the absolute value. Do not throw away these absolute value bars too early. It is a very common mistake to say m minus 3 equals 2, but it's not. Now that the absolute value is by itself, we can split it off. We write m minus 3 equals 2, just like we see it. But then we write the m minus 3 and we make it equal to the opposite, negative 2. And now at this point, we just add 3 and get m equals 5. And over here, we add 3 and get m equals 3 minus 2 is 1. Remember, at any point, you can always stop and rewind, pause if you need to process something. Okay, 14, similar to before, we want to get the common terms together. So that gives me 12r minus 2 less than or equal to 22. I'm going to add 2 to both sides because I want to get my r alone. That cancels. I have 12r is less than or equal to 24. And when I divide by 12, I get r is less than or equal to 2. Now remember, if this had been a negative 12, and I divided by negative 12, I would have to flip that symbol to greater than or equal to negative 2. So case in point, if I just had this, gave you this problem, simple problem, negative 12 less than or equal to 24. If I multiply or divide by a negative number, as soon as I do that, that symbol flips. And I have my negative 2. And if you think about it, I could have moved this over there and that over there, right? Which would have put my R on the positive, on the greater side, and the 22 would be negative. And if it was a negative 12, then it would be positive. And it would have been on the greater than or equal side. So that's why we flip the symbol when we multiply or divide, because it could have been on the other side if we just moved it around. All right, here we're going to multiply by 4, distribute. The 3c plus 5 stays the same, greater than. 4 times 2 is 8c, 5 times 4 is 20. Now, what we just talked about, I like to keep my variables positive. So I would normally, actually I want to do it that way, and I'll go back and do it again. So I'm going to subtract 8c here. Actually, I'm going to do it the other way, sorry. I'm going to move it to the left side, okay? Which means I'm going to move this over here. When I do that, that's going to cancel, and that's going to cancel. I'm going to get negative 5c, because some people like to have their variables on the left side and read left to right, and that's okay. I have 3 minus 8 is negative 5c, still greater than negative 25. As soon as I write this, I'm going to flip that symbol to remember, because I'm dividing by a negative number. So c is less than 5. Okay? Now, again, I'm going to go back. I'll do it this way this time. Whoops. That was an accident. I'm not sure what happened there. This time, I am going to subtract 3c. I'm going to move my variables to the right side and keep it positive, which means I'm going to add 20. Here, the c's cancel, and here, the 20s cancel. So on the left side, I have 25, which is greater than 8 minus 3, 5c. Divide by 5. C is less than 5. Same answer as this, just one is on the left, one's on the right. But we still read it the same way. 5 is greater than C, C is less than 5. Okay, solving and graphing. So this time, I'm going to subtract 3, Nothing fancy going on here. Subtracting does not flip the symbol, only multiplying or dividing. So x is greater than or equal to 4 minus 3 is 1. If I want to go down and do that right now, I can. Or I can wait. Doesn't matter. So on this one, I will. Greater than or equal to 1. Greater than or equal is a solid dot over the 1. And you go this way. Some people graph on here. It just means you have to really shade when you do that, so I prefer to do it above. Coming back here, I have x divided by 3. Well, to undo division, I need to multiply. Whatever I do to one side, I do to the other. 3's cancel, and I have x is less than negative 3. Less than, not less than or equal, so that's an open dot, and less than is going this way. All right. V plus 2 is less than or equal to 4. I'm going to subtract 2, both sides. V is less than or equal to 4 minus 2 is 2. So that would look like this. Preferably without the dip. Here, I need to divide by 2 because it was being multiplied, which gives me V is greater than or equal to negative 5. Oh, well, what happens here then is I have this, but it's going this way. So my final answer is, if you think about this, we kind of just cut it off here. So it's between negative 5 and positive 2. Inclusive because greater than equal, less than or equal. So we use solid dots. All right, this is really an inequality in 3 parts. So whatever we do to one side, we do to all 3 parts. So I'm going to add 4 to get x by itself, which means I need to add 4 here and add 4 here. It's very common to only do it in 2 and kind of throw away one of the numbers. Don't do that. If the lines help you to remind yourself, go for it. So 4 plus 3 is 7. X is left. 4 minus 7 is negative 3, or negative 7 plus 4. I didn't multiply or divide, so this symbol stays, and that symbol stays. Now, if you just look at them separately, this says x is less than 7. And this says x is greater than or equal to negative 3. You technically could have just done this as one problem and done this as another problem, and you'd end up with the same answer. It's just more work that way. This is the preferred way of doing it. X is between negative 3 and 7. Negative 3 has a solid dot. 7 has an open dot. And like the previous problem, in between. And last but not least, we're going to graph an absolute value. So we're going to still add 1 like we did on the previous problems. That means the absolute value of x is less than or equal to 4. But this time when we split this, we got to be careful. X is less than or equal to 4. We just write it as we see it, just like before. And then this, remember, don't we make this side negative 4? Make it opposite? Well, when we do that, we're effectively multiplying by negative 1, so we flip the symbol. So x is greater than or equal to negative 4, solid dot. X is less than or equal to 4, solid dot. And in between. And that's it.